Moving forward with Chapter 11, we want to start talking about solutions in a quantitative fashion. We're going to start talking about concentration. We're going to start with what's called percent concentration. So concentration is the amount of solute dissolved in a certain amount of solution. So concentration is oftentimes given as a singular unit, but every concentration is always a ratio. It is the amount of solute per amount of solution, right? So it's always a fraction, and we have those two, and it's always usually almost always solute per solution. There are going to be a lot of flavors and varieties that we're going to see for our different types of concentration units. But concentration is really important because when we talk about mixtures being useful, the whole point of the utility of mixtures is you can make them in different versions. Right, so you can have very salty water or not very salty water. In this example, these photos, you can put a little bit of red food coloring into water, or you can put way too much red food coloring into water, but you have that flexibility. And what you are changing is the relative ratio of how much solute is in a certain amount of solution. And so one of the reasons why we make it a ratio is, yes, there is a lot of food coloring in this final cup over here, but if you put that same amount of food coloring in a much larger volume of water, it wouldn't turn as red. So by treating it as a ratio of amount of solute to amount of solution, we can normalize it. And then that number, that concentration, corresponds to properties like the colors. So every single same concentration of food coloring in water has the same color. And so that's why we use this. And this is, you can control the properties of a solution by controlling its concentration, right? If you put more salt, the water tastes salty. If you put more food coloring, you can make a more red water. So the most common type of concentration unit, especially outside the world of chemistry, is percent concentration. So a lot of times if you buy product, so there's some isopropyl alcohols here. So, 70% isopropyl versus 91% isopropyl. We know that those percentages correspond to some idea of concentration, right? 70% there is less isopropyl alcohol in there than 91%, which is more. The rest of the percentages are water. And so there's something of that in there. If we're describing salt in water, we also use a percentage. So for example, fresh water is less than say 0.05. Brackish water, so like estuaries up to 3, and then say salt water like in the ocean would be closer to 5%. It's also really important to know if you inject, say, saline into a human, 0.9% is the correct concentration. So your blood has some salt in it, so that's why you don't put pure water into a human. So if you ever gotten hydrated at like a doctor, you got an IV of water, there's always water and, importantly, a little bit of salt in there. And 0.9% sodium chloride matches what's inside of you, so that way they're not putting pure water to dilute your blood, which is not good. So you'll see a lot of concentrations reported as percents, but there's a couple different things that can mean. There's mass percentage, volume percentage, and mass volume percentage. And a lot of it is based around kind of context. Mass, whenever you see mass, that means you're dealing with solids. Volume means you're dealing with liquids. So basically, are you mixing a mass into mass? How are you kind of dealing with it? This mass percentage is still a really common way overall, even though it's mass of solutions, which are usually liquids, but you do kind of just, depending on the context, kind of figure out what's going on. If you're dealing with mass percentage, the units both have to be mass of solute, mass of solution. They need to both be the same unit. Usually it's grams. And again, it's mass of solute in mass of the whole solution. So basically that percent really is clean. If you're dealing with volume percentage, again, needs to be the same volume units. Milliliters is really common when you're dealing with solutions, but it can be anything. But that's pretty common. Mass volume percentage, this does need to be grams in milliliters or kilograms in liters. The reason why, so those don't cancel, right? Those are just different types of units, but we just kind of have this convention of making them grams per milliliter because it's kind of common and it'll get you something close to a percent. Grams, if you had pure water, right, it'd be 1 gram per milliliter. So that'd be like kind of 100%. Yeah, so that's the idea. It's grams per milliliter. And again, We're going to be dealing mostly, when we're going to be talking about these, we're going to deal a lot with mass percentage, since that is really common in the chemistry setting, but you will see other kind of things. And we'll note these W's mean weight, which is mass, and the V's mean volume, which is volume. So let's look at an example of calculating these concentrations, because when we're dealing with concentrations, one of the things we want to be able to know is when we make a solution, what is the concentration of that solution? Because that's going to inform the properties and how it works. So 26 grams of NaCl is dissolved in 500 grams of water. What is the percent concentration?
All right, so what we want is the percent concentration. And so in this case, the name tells us right away it's a concentration, but one of the things we want to be mindful of what the concentration units are, especially their names, because every single concentration unit has an associated equation. The percent of the concentration is equal to the mass of solute divided by mass of solution times 100. And that's it. And so then the question becomes, well, if you want this, what are the other values? What's the mass of the solute and what's the mass of the solution? So we can certainly see that I do have that information available. I have a bunch of masses, right? I have 26 grams and 500 grams. So one of the questions we're going to want to ask is what's the solute, what's the solution? What's the solute, what's the solvent? Sorry. So because 26 grams of NaCl is dissolved, if this is dissolved, this has to be solute, this has to be solvent. We can also see that this is a very small amount of mass, and this is a huge amount of mass relative to the 26. So little component is the solute, bigger component is the solvent. So that's great. So that tells us right away that the 26 grams slots into there. But 500 grams of water, that's the mass of solvent. We want mass of solution. Okay? We are not given the mass of solution, but we can calculate it. The mass of solution is always equal to mass of solute plus mass of solvent. We say that mass is additive. If you'd have two samples of matter and you put them together, the mass of the resulting matter will be just the addition of the two components. So a solution is made of solute and solvent. So if we add those two masses together, we will get the total mass. So we can put those two together. The mass of solute is our 26 grams plus 500 grams for the solvent. So that tells us that the mass of solution is equal to 526 grams. So now we can plug that in. This is one of the most common mistakes, is that we're given the mass of the solvent, and we plug that in for the solution. Most concentration units, we want to describe the solution on the bottom. There is one where we don't, which we'll get to. But generally, we want to have the solution, the whole solution in there. And so we can plug all this in. Percent weight by weight is equal to 26 grams divided by 526 grams times 100. Those mass units, you can see, as we would hope, the grams and grams cancel out. And when we multiply by 100, we end up getting that the percent is equal to 4.9. So in this solution, when we dissolved NaCl into all this water, 4.9% of the mass is NaCl.
So when we're dealing with concentrations, not only do we want to be able to calculate or determine a concentration given the solution that we made, we also want to be able to use a concentration to describe how to make that solution or what is inside of a solution. So for example, what mass of water is contained in 750 milligrams of a 40% ethanol in water solution? So in this case, I want to know what mass of water is contained in. So this is a part of the solution, and I want to know how much is in this particular version of the solution.
So what mass of water is contained in 750 milligrams of a 40% ethanol in water solution? All right, so we know we want mass of water. The values, when we're dealing with these worlds of concentration, a lot of times we want to think it's going to be really helpful to look at, well, what values are present. And when we see this 40%, that is a concentration unit. And so that tells us right away that we can use our equation, that we know we can have our percent is going to be the mass of solute divided by mass of solution. And so we're dealing with this 40% has a bunch of mass units in it. So hopefully that will help us get to mass of water. Oh, whoopsies, we're definitely on the right track. Don't want to forget that there's a 100 on back in there. And so that's great. So one of the things we see again, it's mass of water, is that the solute or the solvent? So because we have this description that it is ethanol in water solution, the ethanol is in the water, so the solute is going to be ethanol and the solvent is going to be water. So this mass of solute, this would actually be ethanol, which is not exactly what we want. And water is not the solution, but I think if we work through, water is a part of this, so we'll see if we can figure some stuff out. So we are given some things. The 40%, whoopsies, goes in right there. 750 milligrams goes in right there. So let's go ahead and plug everything in. 40% is equal to mass of ethanol. And I can specify, once I know what the solute is, I don't need to keep calling it solute. I can call it ethanol. I know what it is. The mass of solution is 750 milligrams. And then the 100 is still just 100. So I want to isolate mass of ethanol. I'm going to solve for that. So divide out the 100. That would cancel out that. The percent sign. 40 divided by 100 times 750 milligrams is going to be equal to 300 milligrams of ethanol. So that's useful. I have a piece of information, not quite what I wanted, but I can figure out the mass of the solute using the concentration equation. There is another relationship that I have that is not necessarily going to jump out based on the values that are given, but is always true that we don't want to forget about. And that is the case that the mass of solution is equal to the mass of solute plus the mass of solvent. And so mass of solvent, that's my water. So this is the actual value that we want. This is the mass of this solvent. So if I can figure out this mass of water, I'd be good to go. So I can write this more specifically. I can say that the mass of the solution is equal to the mass of ethanol plus the mass of water. And so solution is the 750 milligrams I was given. Mass of ethanol is the 300 milligrams I just calculated. So that was why I needed that. I needed to figure that one out. So I can plug those values in. 750 milligrams of solution is equal to 300 milligrams of ethanol plus the mass of water. I can subtract out the 300. Mass of water is going to be 750 milligrams minus 300 milligrams. So that is equal to 450 milligrams. So this relationship, mass of solution is mass of solid plus mass solvent. That's called mass additivity, that those can always add together. And we can always use that in pairing with the concentration equation to work together to figure out. You'd always need to do this if you want to figure out something about the solvent. If we had asked what is the mass of solute, you're done right here. But if you want to know something about the solvent, you always have to go to the sort of secondary relationship of like, how do the solution and the solvent, or the solute and the solvent, combine to give you a solution value. So we'll see some other things like that, but we can always work through that. So this sort of relationship, or this description, right? On the first example, we were just looking at calculating concentration. That's really good. That allows us to characterize solutions. But the other aspect of concentration is that it lets you, this is sort of just a generic relationship, 40%. It doesn't describe this particular solution, and it lets you figure out aspects of this solution. You know you have 750 milliliters of solution. Say you were given this, you had 750 milligrams of a solution, and you had, it's 40%. Well, how much water is in there? How much ethanol is in there? How can you do that? So either you're given a solution and you want to know its components, or you're told you need to make this, right? You need to make 750 milligrams of 40%. How do you do it? Make it, go out and actually.
Along the lines of these percent concentrations, there are also the units called parts per million and parts per billion, which are ppm and ppb. These are very, very similar units where you can see you take a mass of solute divided by a mass of solution and you multiply it by some term. In the percent concentration, we were multiplying by 100. So percent is literally parts per 100. In the case of parts per million and parts per billion, I'm multiplying by the m is million, 10 to the 6 is million, and then b is billion, 10 to the 9 is billion. So these concentration units are used in the same way, and working with the equation is the exact same as the percentage units, but you use it in situations where you're dealing with very dilute solutions, where multiplying by a million leads to a reasonable example. So in our examples, we saw percentages of like 5 or 40%. So when you multiplied by 100, you got a reasonable number. We use parts per million or parts per billion, where multiplying by a million leads to, like, say, 1 part per million. So 1 gram of solute for every 1 million grams of solution. So these are very dilute solutions. Usually this is commonly used in situations where it's like, how much lead is in your water, where the limit on that should be very, very low, because you really don't want any lead in your water. There we go. First video down. Participation 125 is what we're looking for our questions on. That one's going to be due Tuesday. Nothing so far, but we still got plenty more videos, plenty more solute concentrations to learn about. Wednesday, you also have the midweek 3 homework, as we've seen. I'll cover this set of videos, this end of chapter 11, or second half of chapter 11, and then we'll do the lab on Wednesday as well. Make sure you take care of the pre-lab and technique assignments beforehand, and then get the notebook filled out if you're leader technician, whatever, based on your role. If you have any questions about completing any of these assignments or any of the content that we're covering here, please do not hesitate to reach out. Otherwise, just getting started here. Welcome to week 3, finishing up chapter 11. See you in the next video.